Our next lesson is called Slope in the Real World. We'll start with the first activity. List some examples of how slope is used in daily life. So if you would, please pause the video and brainstorm some examples of how slope is used in daily life on your own. Then resume the video to see some examples that we came up with. Okay, now that you've had a chance to brainstorm on your own, here's some examples that we have. Mountains, we know we have uphill and downhill. Roads, driving up a hill, down a hill on the roads when you're out there. Roof pitches, if you actually look at the top of the roof, there's an incline or a decline depending on how you're looking at it. Slides, think about going to the park. If you're a skier, the ski slopes. And I'm sure there are other examples that you have come up with as well. So to move on with our lesson in slope in the real world, I want you to recall what slope is. Slope is written as a ratio of the vertical change, which is the rise, to the horizontal change, which is the run. So we wrote M equals rise over run. And this is between any 2 points on a line. Because of this, slope is also referred to as a rate of change. So that means when you see a question that asks about slope, it also means it's asking for the rate of change. If you see a question that asks about rate of change, it's also referring to finding the slope. So when you're reading a description from a real life situation, you find the slope by finding the rate that compares two quantities. So if you think back to what you learned previously about rate, rate is something like miles per hour, two different units that are being compared. Rate of change means the same thing as slope, so that will help us identify the slope or rate of change in real-world situations. So the directions for our next section say, identify the slope in each situation. Underline the part of the description that you used to determine the answer. So in our first one, Ellie just got her first cell phone plan. She pays $75 per month plus a $150 activation fee. After 10 months, she has spent a total of $940. The question is, what is the slope or rate of change? So we want to go back to the problem and find the rate. What was comparing two quantities? So she pays $79 per month is our rate of change or slope. $150 was just a fee, a one-time thing, and the total is $940. None of that has to do with what the slope or rate of change is. So now that we've found it, we know that the slope is 79. Now, because it's 79 per month, like 79 over 1, this is also an example of a unit rate. If you are a unit rate, you have a denominator of 1. So as we go through the lesson, we'll also pay attention to which ones have been simplified down to a unit rate. Our next one, Maggie drove 45 miles per hour for 8 hours. So we're looking for the rate that's comparing the two quantities. I see 45 miles per hour, so miles and hours. So that means my slope or rate of change is 45. Again, that's coming from 45 miles per hour, which is 45 over 1, which means this one is also a unit rate. Gas cost $1.89 per gallon, and an oil change is $29.99. Ellis spent $41.33 at the service station. What is the slope or rate of change? So when reading this problem, I want to find the rate that's comparing two quantities, and I see money per gallon. Okay, so that means my slope is $1.89 or 1.89. Now again, because it's per gallon, that's 1, this is also a unit rate. So now that we know how to actually find the slope or rate of change in the description, Our next phase is we have to be able to describe what it means. So if you would go on to the next section of your lesson, this part asks us to identify the slope in each situation, underline the part of the description that you use to determine the answer, and this time explain what each slope means in context of the situation. So remember, slope is the same thing as rate of change. So we're looking for the rate comparing the different quantities when we read the description. Ryan is building a deck. He needs pieces of wood that are 8 feet long. Each 8-foot piece costs $2.75. He has already spent $124.62 on other supplies. Identify the slope or rate of change. So for this one, he's buying pieces of wood that are 8 feet long. And then we see this statement that each 8-foot piece costs $2.75. So here, yes, the piece is 8 feet long, but really we want each piece costs $2.75. That is your rate of change or slope. So we have 2.75. Now remember, this is $2.75 for each piece. That's one piece. So that means this is also a unit rate. Now the added part in this section is that we have to explain what it means. So what does that 2.5 mean or represent in the problem? Well, if we look back to it, it says each 8-foot piece costs $2.75. So we'll say the slope / rate of change is, so in this case, it's the cost of one 8-foot piece of wood. So we're moving to the point where not only are we just picking out the number, but we're really explaining what that number represents in the problem. Let's try the next one. A new ski resort has opened up in a neighboring town. One of the ski runs rises 8 feet for every horizontal change of 10 feet. What is the slope of the ski run? So this one's a little bit different. We're not seeing real life units as far as money per gallon or miles per hour, but we are given a ratio within the actual problem. So it says one of the ski runs rises 8 feet for every horizontal change of 10 feet. So remember, slope is rise over run. Rise is your vertical change. Run is your horizontal change. So that means when they tell me it's rising 8 feet, that 8 should go in top of the fraction, and horizontal change means the run, so 10 should go on the bottom. So that's our slope or rate of change. At this particular time, this is not a fully reduced fraction. So I want to reduce it if possible. If I look at 8 and 10, I know that they're both even numbers, and therefore they can both be divided by 2. So I want to reduce it to simplest form, which makes this 4/5. This is the first fraction technically that we've had, or slope or unit rate, or slope or rate of change that we've had that's not a unit rate. Okay? So this is just the simplified version. If we wanted to find the unit rate, we could. We would do 4 divided by 5, which is equal to 0.8. And this would be the unit rate. But our simplified slope or rate of change is 4/5. So now we're going to explain what that means. So now that we've simplified it down to 4/5, remember the number on top is your vertical change. So this means the slope / rate of change means that, so we're talking about a ski run, so we're going to say the ski run on top, remember, is a rise, so we're going to say it rises 4 feet, And that's for every horizontal change of the number on the bottom, which is 5 feet. So again, there's two parts to this. First, identifying just the number, but then being able to explain what it means in the real life situation that's being described. So now I'd like you to try the think about it question. It says, how would you describe the slope of the following situation? How is it different than the previous examples? It says the temperature is 15 degrees and it is expected to fall 2 degrees each hour during the night. I'd like you to pause the video and try this question on your own, and when you're ready to go over the answer, you can resume the video. Okay, you've had a chance to try the question on your own, so let's go over the answer. I still underlined where my slope or rate of change was. That should have been fall 2 degrees each hour. The key word there being fall. So because of that word, that means my slope is going down. So the slope or rate of change is actually -2 because the temperature is falling, which means going down. All other examples had a positive or increasing slope or rate of change. So be careful when you're reading these explanations, these descriptions, that when you're explaining them, you're really slowing down and looking for those key words. Is the slope or rate of change a positive number? Is it describing an increase? Or is it a negative number? There are a few situations out there where you may have to include a negative as part of your slope based on the real life problem that you're trying to describe. And that concludes our lesson on slope in the real world.